Good morning. Okay, just checking how this works. Good morning, everybody. My name is Rita, and I'm going to present you an integrated regional prioritization framework for seismic retrofitting of residential buildings, which was a work that we have done in Pavia, use Pavia, me and my supervisor, Dr. Rita Monteiro, Professor Rita Bento from Lisbon, and Professor Rita Monteiro from use Pavia. So first, why this topic? So we all know that the European building stock is facing a dual challenge when it comes to its building stock. Most of the buildings were built before the introduction of modern seismic regulations, which make them very seismic vulnerable. On top of this, approximately 75% of these buildings is energy inefficiency, which leads to a high energy consumption and high carbon emissions, and the building sector alone is responsible for 40% of the total European Union energy consumption and 36% of its CO2 emissions. So, based on these facts, we know that a renovation of the building stock is very important. And how can we do this? So, starting with the deficiencies of these buildings, we can retrofit them both in like structural retrofit and energy retrofit. Most policies are just focusing on energy efficiency, leaving the structural part behind, and this doesn't make much sense because by just improving one part, let's say if there's an event happening, we just again lost money. So it's important to think of this as a multi-retrofitting scheme, so an integrated retrofitting scheme. And if we want to think about this in a regional way, so if you want to think about this in a large scale, it's important to understand which regions are more important than others. So it's important to perform prioritization analysis. So basically, like, where should we start? Thinking, for example, of a country, of a region, where should we start? So for this reason, I will show you an analysis that we have done, which basically combines three main pillars. So the seismic risk, the energy performance, and the socio-economic vulnerability. The first two, seismic risk and energy performance, as I said, because these are the biggest challenge of the building stock. And then the socio-economic vulnerability, because we know that disasters disasters affect in different ways different sectors of society. So basically, we proceed to analyze these indicators independently by different metrics that I'm going to show you soon. And then we proceed to combine each indicator. So we combine each of these indicators in a pair, so each two, by equally averaging them. So we have what would be the result in terms of combining the seismic risk indicator with the energy performance indicator, the seismic risk with the socio-economic vulnerability indicator, and then energy with the socio-economic vulnerability. And then we proceed to combine everything and try to understand what would be the results of this. So, starting with the seismic risk, as several of you presented in this conference, we know that seismic risk is evaluated by combining three different sector analysis: hazard, exposure, and vulnerability. By the way, I forgot to tell you, I'm going to show you the results of this framework applied to the case study of Portugal. Why? Because I'm Portuguese. So, starting with the hazards, we have conducted a PSHA analysis in Portugal, employing the latest European seismic hazard model and using OpenQuake. Then we have used the latest or the most updated GEM exposure model, and basically we have around 3 million residential buildings, a total replacement cost of around 600 billion euros, and a more or less equal distributed of typologies of buildings. So we have 51% reinforced concrete and 43% mansardy buildings. I want to highlight that these regions that you see here, highlighted are more or less equal to 51% of the total replacement cost of the country. So we have a very not unified distribution of replacement cost and number of buildings, etc. Then we have used different fragility curves from multiple sources mostly Portuguese, to try to characterize them as much as we can, or the best we can, the Portuguese building stock. We have converted these fragility curves into vulnerability curves, both in terms of economic losses and fatalities. And we proceed to calculate the metrics that we are interested in, which are basically the average annual economic loss and the average annual loss of life. The results show us, the results are very in line with what we obtain in the hazard analysis, having these bigger regions here, so the area of Lisbon and the area of the south of Portugal with the higher economic losses and fatalities. Then, having obtained each one of these metrics, we combine them. So we divided them by the number of buildings, the replacement costs, the total, the average number of occupants, and we have calculated the seismic risk indicator, which is basically the average of these three metrics together. The plot that I'm showing you on the right is the results of this seismic risk indicator, so we can see both on the map and on the bar plots what are the, or how would the regions should be prioritized. So we see that Faro is the region with the highest seismic risk indicator, followed by the region of Lisbon and around Lisbon, which again makes sense as we saw in the previous slide with the metrics that we have calculated. Then for the energy performance, we have used two different analyses. We have, or two different components. We have used the energy demand, which is given by the cooling and the heating degree days of the country, which are basically the heating and the cooling requirements to obtain a comfort temperature in the building. And you can see from the map that the regions that are higher, darker, so the dark blue are the regions with a higher demand, both in terms of cooling and heating, while the lighter regions are the ones that don't require that are less demanding. And you can see that obviously, there's different patterns for different regions. Then we also have used the energy consumption of the country, and we have obtained this from a Portuguese database, so it's a government data. And to calculate the carbon emissions, we basically just used an average emission factor and the carbon emission cost. So of course, since we are only multiplying by some factors, the distribution, or it's the same between the two bar plots that I'm showing you on the right. Again, we can see that Lisbon and Porto are the regions with higher energy consumption, and this total consumption is approximately 41% of the total energy consumption of the whole country, sorry. Then we did exactly the same, so we decided how we wanted to use these results in different metrics, so we have basically, again, grouped or used the results with other parameters, such as the area of each dwelling, the number of buildings, the heating degree days, to try to obtain different metrics that we think it's important to characterize the energy inefficiency of the country, of a region, sorry. And we proceed to calculate the energy indicator, once again, by averaging all of these metrics. I'm showing you the results in this, again, map and the bar plot. And we can see that Lisbon is the region that shows higher need of, let's say, energy retrofitting, or higher need of ACT. Yes. Then, as I said, we also decided to include the socioeconomic vulnerability, because we believe, and it is proved, that disasters affect different regions of society in different ways. And for this, we have used three different components. So the socioeconomic vulnerability index, the energy poverty, and the earthquake risk awareness. Each one of them trying to measure different different components of, let's say, socioeconomic vulnerability. The first one, socioeconomic vulnerability index, is composed by two different European index. So it's, again, European data. The second one, energy poverty, it basically quantifies the inability of houses to access basic energy needs. And we have used a Portuguese study on this that quantified the energy vulnerability of different municipalities in Portugal. And then for the earthquake risk awareness, we have also used a study in Portugal that characterized the perception of people in different regions of Portugal to different hazards. So not just earthquakes, but of course for this case we are using the earthquake risk, earthquake part. Once again, we have used these components to quantify the socioeconomic vulnerability indicator by averaging them, and we have again the map and the bar plot that show us what are the regions that have a higher prioritization in terms of socioeconomic vulnerability. The next step, as I show you on the beginning of this presentation, is to proceed to merge each indicator and try to understand what would happen if we wanted to just focus on one and not the other, or the three of them, or the two of them. So we have, for example, seismic and energy-based prioritization, so we can say it's something like, if we are only thinking in engineering term, so if we are only thinking about, okay, let's change the seismic or the structural performance of these buildings and the energy performance of these buildings, we can see in the map that we obtain the region, again, the region of Lisbon and Faro as the highest prioritization regions. Then if we proceed to combine the seismic and the socioeconomic based indicators, we obtain a different pattern, and therefore, and finally, if we combine everything, we obtain a new pattern. And it's important, I mean, these three maps or four maps together indicate that if we choose different, by choosing different priority, no, sorry, not priority, but by choosing different sectors that we think it's important to prioritize, we obtain very different distribution of prioritization. Yes. So, I was fast. To conclude, we basically show you a framework that prioritizes regions based on the seismic risk, energy performance, and socioeconomic vulnerability. We saw that by combining the different indicators, we obtain very different results, and this is good to support a more balanced resource allocation. And future studies could focus on higher resolution analysis. So, for example, we could now that we saw, as I show you on the last slide, now that we saw that, for example, Lisbon is the region that needs higher prioritization, we could focus just in Lisbon and understand what's happening there, or how is it distributed by the different typologies of buildings that exist there, etc. We could also include different sectors, so I show you three, but inside of, first we could include more, and inside of these three we can also include more. And finally, all the data that we have used, so all the data that we have used should be updated, because most of this data is given yearly. So to keep updated, we should keep checking the data. And finally, so as I told you, I presented this case study for Portugal because I'm from Portugal, but I'm in a national Italian conference. So what about Italy? I'm not showing you my work, but I just want to tell you that if you are interested to understand what would happen what would happen in Italy, how this prioritization framework would, or the results of this prioritization framework would happen, you can check the paper of my supervisors, Rita Monteiro and Quadro, and yeah, and that's it. Thank you.